All right, let's look at page 3 of your worksheet. I know this is a really long worksheet and a lot of information, but I promise you we're going to be using it for the rest of the course, so we really need it. So page 3 of the worksheet is the information for Molly and Arthur Weasley, and it's giving us information for 4 different traits: for hair color, for freckles, for eye color, and for tongue rolling. And it tells you for hair color, this is the one we're going to look at. It says for hair color, capital H equals brown and little h equals red. Okay, so these are our phenotypes. These are our alleles for the trait hair color. Okay, now when we look at the Molly Weasley category, we see that she has 2 different things under her name. It lists her phenotype, and then there's a blank column for her genotype. So for Molly Weasley's hair, her phenotype is homozygous red. All right, when we hear homozygous, we should immediately think homo-samo. She's going to have the same alleles. Her hair is red, is her phenotype. Red is lowercase h. So Molly's phenotype is homozygous red, meaning her genotype has to be little h, little h. So this is Molly. Okay? Now, let's look at Arthur. Arthur has homozygous red hair, just like Molly. Okay? So Arthur has little h as well. Now we're going to take these 2 genotypes for this trait, and we're going to put them in the Punnett square that says hair color. So we have a Punnett square here. Put the mom and the dad on the sides. We have little h, little h, little h, little h. Well, we already know we don't have any big h's in there. So this is a really easy Punnett square to finish. Okay? Lowercase, lowercase h in every single square. That means all of their offspring are going to be little h, homozygous, recessive, which is red. So all of their children are going to have red hair. All right, so now what we're going to do is we're going to go to page 4 of the worksheet and complete these sibling tables. We have 4 siblings here. Okay, don't worry about if who's Ron or who's Fred or George. That we're not going to worry about that. We're just going to have 4 siblings here. For sibling 1, I'm going to pick any of these 4 squares. It does not matter which one I pick. Okay? And I'm going to assign sibling 1 that genotype. Okay? So sibling 1, I'm going to give him this first square here, and I would write under genotype for hair color HH. The next thing says, is that genotype heterozygous or homozygous? Well, it's the same, so it has to be homozygous. The next column says, is it dominant or is it recessive? Well, we have lowercase, so we know that it is recessive. And the very last column says the phenotype. What does this child's hair look like? Well, we know that lowercase is recessive. That means red, so red would be the phenotype. Then you would go to sibling 2 for hair color. Pick any of these squares. Let's say we're going to pick this one for number 2. And we fill in the information. And maybe we pick this square for number 3 and we fill in the information. And we pick this one for number 4 and we fill in the information. It does not matter which square you're picking each time, as long as you pick one square for each sibling and don't use the same one over and over again. Okay? In this one, it doesn't matter too much because they're all little h, so it kind of doesn't matter. But if we had a Punnett square that was something like this, something like that, okay? That's not a true Punnett square, but we have these 4 things. One sibling would be assigned to this one. There's only one little h, so we would not assign that to another sibling. Okay, it doesn't matter which sibling you give it to, but only give it to one. Okay, there's only one genotype for capital H, so then you would assign that one capital H. And then this one for the third one, this one for the fourth one. Okay? If you have any problems, make sure you ask me and I'll help you out.